Hi Year 9s, welcome to this video on simplifying algebraic expressions, and this is going to help you understand and be able to complete exercise 3.4. So before I get on to some worked examples for you, I just want to recap on what like terms are. So like terms are terms that have identical variables, so identical groups of letters, as well as powers. Now we can see here from this first example that this one here, RT, and this one here, so 5RT and 2RT, they have groups of identical variables and powers. So that means that these two terms, I'll just get a thinner pen, that these two terms here can be added. And you can see that in this term here, I've also highlighted the addition sign in front of it, and that means that we're going to plus these two terms together. And what I end up with is 7RT, and then this term here, there was no other like term for it, so that goes on the end there. Okay, so we just did the first example before. Now I'm going to do this second one here, and you'll notice with this one that we've got terms that have powers greater than 1. Okay, so I can see here that I've got a positive 6g to the power of 2. And I can see here as well that I've got another term with g to the power of 2 in it, that's positive 3. Now you might be thinking, what about this one here? Is this a like term as well? No, it's not, and that's because I could write a little one up the top here. The power of this g is only to the power of 1, not to the power of 2. And there's no like term for the t in this expression, so what we need to do is combine those two terms that I've circled. So we can see we've got positive 3g squared plus 6g squared equals 9g squared, and then these two terms tack on the end. Okay, so we're going to follow the same process now to complete these or simplify these algebraic expressions. So we can see here we've got 14p plus 3p plus 5p. The variables all are p in each of the terms, and that p is raised to the power of 1. So I can actually go ahead right now and circle each of these expressions because they are all like terms, which means underneath here I've got 14 plus 3 plus 5, so that is 1722p. Okay, let's have a look at this second example down here. A little bit trickier. I've got this one here that has a variable m squared and then an n. And then I've got this one here. Also has m squared and then an n, so the same grouping of variables as well as powers. In this one, I've also got another pair of like terms. So what I'm going to do next is actually deal with each of these two different like terms separately. So on my next line, I've got 4m squared n here, and then I'm going to subtract that from negative 3m squared n. So I'm going to write that out in full just so we can follow along a little bit better. So 4m squared n subtract 3m squared n, and then I'm going to put our other group of like terms on the end. Okay, and now that's ready to really group them up because they're next to each other. So I've got 4m squared n here, and I'm going to subtract 3m squared n from that, which gives me simply m squared n. We could put a 1 in front of here, but it's not necessary because I already know that this is only one group of m squared n. And then here, over this side, I've got 3n plus 8n, which is positive 11n. And that's my final answer down here. And you might like to pause this video right now and copy down these examples. These would be really good ones to have in your book. Okay, this becomes a little bit trickier because now we've got a multiplication sign in between. And to make it a little bit easier for us, what I'm going to do is write out the expanded form of this. So this is really negative 5 times negative 2. So all I've done there is multiplied the letters together. And then what I've got is in the first expression I've got an m multiplied by m, and I've got another one in the second expression, and then I've also got an n on the end. And they're all being multiplied together because there's a multiplication sign in between each of those individual pieces of the equation as well. So if I combine those, I then have this bit here becomes a negative 5 multiplied by negative 2. So we've got a negative and a negative. So that is going to make a positive. So I've got 10. And then I've got 2m, lots of m, so m times m is m squared. We know that from indices. And then I've only got one n. And this is my final answer. So I'm going to do the same for this expression here. Write it out. So I'm going to take account of my letters first. So I've got, sorry, not of my letters, of my numbers first. So I've got 3 times 3, and then I've got p's times p times p, and then on the end I've got q. So q, and this one here is actually a q squared, so I'm going to expand that right out and write q. Well, let's write q squared because then we can practice our index laws, adding our powers. And then we're going to combine that like we did with the last one. So the letters 3 times 3 is 9. We've got 2 p's, so p squared. And with this one here, I could have expanded the q squared out and have written that as q multiplied by q. But instead what I'm going to do here is actually add my exponents. So I've got q to the power of 1 plus q to the power of 2 is q to the power of 3. And that's that question done. And again, you might like to stop and write these examples down. If not, let's get ready to move on to these next questions, which are a little bit trickier again. Although not too bad, actually. The first one's not too bad. So, first question, simplify the following. The first one's okay because we've got these numbers here, so all we have to do is take account of those numbers. So 16 divided by 4 is 4. So I'm left with, I'll just choose my colour, I'm left with 4x for the first one. For the second one's a little bit trickier. So I'm going to follow the same process where I take account of my numbers. So I've got 2 divided by 4, and then I've got x squared. Now we're dividing that x squared by its like term, which is x, and when we divide our exponents, we know that we subtract. So I've got x to subtract the x on the bottom, which is x to the power of 1. And then I've got b, I've only got one b. And then on the end I've got d subtract d, which is actually d, I'll just write it up here, d to the power of 1 subtract d to the power of 1 equals d to the power of 0. And as you all know, that equals 1. So we don't need to write that in our equation. We could, but it would not change it. So, simplifying our equation further, we've got 1/2, because we know that 2/4 is the same as 1/2, and then we've got x to the power of 1 and b tacked on the end there. And I can also write x to the power of 1 as just x. And I can also put these letters on top or on the numerator of my fraction out here. So I'll go ahead and do that. So finally, actually I'll write it in black. We've got xb divided by 2. Okay, so that's the same as saying 1/2 multiplied by x multiplied by b. Mathematicians just like to use this way as it's a little bit more simple. Okay, and our final question here. So we're going to treat it in exactly the same way. Numbers first, and I'll write it out. 18 divided by 6. Then I'm going to look at my f's. F to the power of 2, subtract what's on that denominator, which is just f, or f to the power of 1. And then I've got my g on the end. So let me choose another colour. I've got g to the 1 minus 1. Writing that out on the next line, which will be our final answer, we've got 18 divided by 6 is 3, f to the power of 1, and we know again that g to the 0 is just 1, so it doesn't change this. If we multiplied this by 1, it would be the same thing. Okay, now the last slide, that's actually all the examples I've got for you today. So the last slide is telling you which questions to do. So today, Year 9s, I'd like you to get up to question 6, so all the questions in your column of your work guide up to question 6. And for those of you who get time, you can have a go at completing questions 7, 10 and 12. There's some questions that are a little bit more challenging. Okay, I'll see you all next lesson.